Hey, and welcome back to another Master Math Classic Math video. We've got a good one today. We've got polynomial identities. We're in the Algebra 2 course in Khan Academy, and we're going to rock on some polynomial identities. Question number 1. Which of the equations are true identities? And it's giving us two equations, A and B. In order for equations to be identities, it's got to meet this definition. I'm going to go ahead and read it right here. Polynomial identities are equations that are true for all possible values of the variable. I'm going to go ahead and pause that and write a much simpler definition, or give you a much easier way of understanding this, because I was confused when I read this definition. The way of understanding this definition is, are the expressions in the equation the same? So if you look at the first equation it gives us, it's giving us an expression on the left, n to the third plus 3n squared plus 2n. And it's giving us, it's saying, is that expression equal to this expression in yellow? Are those two the same expressions? What I mean when I say that is this. If the expression on the left equals the expression on the right, then it is in fact an identity. Here's the easiest way to understand that. Example, x is the expression on the left, equals x is the expression on the right. Are these two expressions the same? Yes, we can see that they're exactly the same, right? So any number I choose for the variable, whether it be 3, negative 3, if I put that number in, the equation is true. So we're trying to figure out, can we rewrite green to look like yellow, or can we rewrite yellow to look like green? Let's go ahead and get into it. When we look at these two expressions, we can see that the expression on the left is in standard form, and the expression on the right is in factored form. And so there's one of two ways of figuring out if the two are the same, right? I can factor the expression in standard form and see if it looks like the expression on the right, or I can multiply the factored form expression and put it in standard form to see if it's the same as our green expression. I'm going to elect to multiply the factored form expression to compare it to the standard form expression. So let's go ahead and do that right now. So if I'm multiplying here, the first thing I'm going to do is, and we've got three factors, right? So we've got to multiply this factor to this factor to this factor. So we're multiplying, so it doesn't matter what order we multiply. I'm going to do the easiest thing first. I'm going to multiply this n into the parentheses. I'm going to distribute, right? I'm going to distribute this n to the parentheses it's being multiplied to. So I got n times n gives us n squared, plus n times 1 gives us 1n. Cool? And then we're left with times. So I got to kind of put this in parentheses still, right? Because everything's being multiplied to the n plus 2. And now I can multiply n squared through, and I can multiply, I'll use a different color to show you that I'm multiplying, n through, right? And so when we multiply this out, our new expression is n squared times n is n to the third, n squared times 2 is 2n to the second, and then we've got n times n gives us n squared, and 1n times 2 gives us 2n. Cool? And so now I got some like terms I can combine here. We've got some squareds. Cool, those are both squareds, so we can combine those. And our highest exponent term is n to the third. That was first. 2 plus 1 is 3, n squared plus 2n. Boom. And so now I've got this in standard form. I'm going to compare it to the one expression on the left and see if this is the same. Are they the same? Yes, they're exactly the same. Cool. So is equation A an identity? Yes, it is, because it's the same exact expression, just written in a different form. Let's look at equation B. The blue expression, we got the red. We're going to compare to see these two. And then we look at these both. The one on the right is in standard form clearly, and the one on the left, it is not necessarily in factored form. But if we multiply this out, then we can compare to see if it looks like the one on the right, right? So we got a plus 3 squared. This is a perfect square. And so I'm going to use the perfect square formula. I'm going to go ahead and write this the way you know perfect square. If you don't know perfect square yet, essentially it's a squared, and then we multiply a times 3 times 2, which is 6a plus 9. If that didn't make sense to you, I'd encourage you to go back and review the formula for perfect squares. Now we've got like terms. We got 9 and negative 9. Those zero out. We can simplify those. And so then we're left with a squared plus 6a. And now we're comparing it to see if it looks like the expression on the right. In fact, they are the exact same. So we can say that the B equation is also an identity. And so I'm going to go ahead and mark it. Now, before I move on, I feel like I have to give you the shortcuts here. So if I want to know if two expressions are identities, and it's giving me multiple choice. This is what I'm going to do. I'm going to split the screen here. If I want to know if those two expressions are the same, then I'm going to turn those expressions into lines, and then I'm going to see if the lines are the same. And so I'm going to type in the expression on the left, n to the third power plus 3n squared plus 2n. And I'm going to change these variables to x's because I want lines, so I'm going to just switch these to x's. I know they're n's, but they're x's because I want a line. Now we've got a line. Cool. So here's our left expression, right? Looks like this. Kind of zoom out, but I'm going to kind of zoom in because there's a curve there. I want to know if that left expression is the same as the right expression, so I'm going to type in the right expression, but this time I'm going to switch the x's, the n's for x's. Cool. X plus 1. Sweet. Shalongo can't type. Yes, he can. Yes, he can. Yes, he can type. And you can see, here are the two lines, right? No lines. Here's the first line, the expression on the left. When I turn the second expression on, you can see that the line matches up identical. It is the same exact line, right? So like, I take them both away, I put this one back. The lines are the same. If the lines are the same, then the expressions are the same, then they're identities. That's the shortcut here. Okay, here we have example number 2, and essentially, we could go ahead and we can multiply them both out, right? We can multiply a to 2a, boom, boom, just like this, and we can multiply this all the way through, and then we can compare, right? But I'm not going to do that. I'm going to use a shortcut. We want to see if this works, like if this strategy works. I'm going to convert this first expression to a line. So I'm going to take out a, and I'm going to make it an x. And since I've got another variable here, I've got to use another variable. The other second graphing variable we use is y, so we're going to use b. We're going to use y for b. Cool. We got 2x plus 1. And now you can see I'm not getting a line. And I know I'm not getting a line because it's telling me I'm not getting a line. And it gets a little bit more complicated with y. And so since we're graphing, we just want the line. We're just going to make this equation equal some arbitrary number. I'm going to choose 7. No, I'm going to choose 0. I want it to be a straight line. Cool. And so then when I type in the second expression, I'm also going to set it equal to 0, if that makes sense. So we got x is a, so 2x plus 2b, which is y, plus 1 equals 0. So I've got to make sure that they equal the same number. If I make this equal a different number, then it's going to start getting confusing. So that's the strategy. I chose an arbitrary random number here. I chose 0 to see the line, right? And so now we've got both lines, and we can see the lines are not the same. They are not the same line, and so the expressions are not the same. And even if I change this to 8 and I change this to 8, okay, the lines are not the same. No matter what the lines look like, they're not the same line. So we know that expression A is not equivalent. We know that equation A does not have expressions that are equivalent. Let's try equation B. So here we have equation A. I've typed in, I've replaced the x's with the n's with x's. So there's our equation for the left expression, and then our equation for the right expression I've got typed in. And now we're looking to see where the lines are. I'm not seeing any lines. I'm only seeing one line right now. Ooh, then I see a bunch of dots. That's a giveaway too. So sometimes when you type in the second one, you don't see the line. There it is. Boom, I put this one back on. Cool, we can see that the lines match up. So if the expressions are the same, then the equation is an identity. That was only the case for B. It's a little bit different. Here it's saying it's giving us an equation, and Sydney's doing a bunch of operations to see if the expression on the left can be written as the expression on the right. And we've got to figure out if she's made any steps here. So we could follow her steps, right? Like here, what did she do first? She found her greatest common factor. Here, she multiplied, right? We could totally do that, and that would totally be okay, but I'm just going to see if each step is right using Desmos. It's going to be easier to see if she's made a mistake, right? So if I'm using Desmos to do this, what I'm going to do is I'm going to type in the expression that she's looking at when she's going on, right? So I've got the red one in, and I've got that right here. And if I type in step 1, if I type the equation in with step 1, if she's performed steps correctly using math, then it should be the same equation, so it should look like the original. So I'm just going to type in the equation she's got in step 1 to see if it matches up with the line that we currently have in Desmos. And I kind of adjusted the zoom in Desmos so I could see that W. What I mean is, like, if I didn't adjust, you know, you wouldn't see the lines as good. We got this one, and then I got to put in this, whoopsies, definitely want to be able to see the lines. And then put in this second set of parentheses here that she's got, x squared. So yes, it's a lot of typing. but this is guaranteed to work, right? So are the equations the same? Yes, they're the same. They match up. 2, I've typed in step 2 right here. Does it match up? Yes, it matches up with the previous lines. So far, so good. On equation step 3, right, the equation, again, if I zoom in, it's still matching up. Like, I've got a good zoom. It's matching up with the previous equations, right? So far, she hasn't made any mistakes because all 3 expressions are equivalent, are the same. And I know that because all the lines are the same. The 4th step in Desmos, and you can see Sydney is absolutely crushing her math right now, right? Like, she's absolutely multiplying correctly, she's factoring correctly, she's using the identities that we've already learned, and it's awesome. Here's the last one. Let's see if she's brought this one home or if she like messed up on the very last step. So 36x squared plus 162. And boom, you can see, yeah, they all match up. So she hasn't made a single mistake on any of these problems. We know that she's right. Let's move on. That's that. Done. And we've got Alina here. Alina's trying to see if the left expression can be manipulated to look like the right expression. I've got the first expression in. I've also got the second expression in, which would be the first step, right? And as soon as I click this one on, you're noticing something happen in Desmos. You notice that the parabolas are not lining up. So these expressions cannot be the same. Let me make sure I type this in correctly. Boom, boom, boom. So I have not made any mistakes with how I transferred this in over to Desmos. The lines are clearly not matching up. So she has clearly made a mistake on step 1. And if I had to say where she made her mistake, she made her mistake when she multiplied these out. Here she's good. No, she's not even good on the right. She's not good on the left, and she's not good on the right. This would be 2 times. Actually, she is good on the left. On the right, she's no good. These should be minus signs. Anyways, 12-minute video. Good luck.